This video is on how to expand a difference of two squares. So there's two questions I'm hoping you will be asking when you hear the words a difference of two squares. And the first one is, what does it look like? And the second question is, why is it called a difference of two squares? So the first thing I want you to be aware of is the fact that a difference of two squares has a very distinct look. Firstly, when we write it in factorized form, or in other words with brackets, it consists of two terms in each bracket, so we're going to have a binomial expression in both brackets. And then I think the easy thing about the expressions is they're very similar. You're going to have the same looking terms in both brackets, but in one of the brackets you need a plus sign, and the other bracket you'll need a subtraction sign or a minus sign. And sometimes students will say to me, well, does it matter which bracket the minus goes in? Well, I want you to remember that with multiplication, order doesn't matter. If I multiply 3 by 5, I'll get 15. And if I multiply 5 by 3, I'll also get 15. So whichever bracket comes first, it's not a big deal because the overall result will be exactly the same. So quick answer is no. A minus in either bracket is fine as long as you have one of each sign in the bracket. So all of these expressions that I'm writing are examples of a difference of two squares. So I could have 2m squared minus 9, 2m squared plus 9. It can get more complicated, I guess, something like this. But what you can see is the terms are the same, but in one bracket they're joined by a minus, and in one bracket they're joined by a plus. So the next question is, well, why is it called a difference of two squares? Well, if I pick my first expression over here that I wrote, let's expand it. Let's expand it using FOIL, like we learnt in the last video. And so I'm going to do firsts, that gives me a squared. Then I'm going to do lasts, or outsides, that gives me minus 4a. Insides, that gives me plus 4a. And lasts, that gives me minus 16. So you can read that that's a 4. That's a 4. So what I'm hoping you'll notice is because these two terms are equal in magnitude but opposite in sign, that just means it's the same number but they have opposite signs. What's going to happen is every time you do FOIL, you're going to end up with two terms that look very similar but they will have the opposite sign. And what will happen when two terms look the same but have the opposite sign? Well, they're going to cancel because minus 4a plus 4a gives you 0. And so really all I'm going to end up with is a squared minus 16. And if you look at that expression, the word difference in mathematics has a meaning. When we say the word difference, if I said my friend's 20 years old and I'm 14 years old, what's the difference in our ages? Well, we would do what? To find the difference in our ages, we would subtract. The word difference in mathematics means subtraction. So when we say a difference of two squares, well, that explains firstly why we have the minus sign. Okay, two squares, well, where are my two squares coming from? Well, here is one of them. There's my first square, that's 16. 16 is 4 squared. And my other square comes from over here. It's a squared. So what I have is I have two square terms, one here and one here, and then I have the difference of them. And that's why it's called a difference of two squares. And when you have a difference of two squares, you will always only end up with two terms. And the reason why you will always only end up with two terms is because these middle terms here will cancel, leaving you with just the first term and the last term in your expansion. So you do not need to use FOIL to expand a difference of two squares. So how will I expand a difference of two squares? Well, we're going to make life easy for ourselves. We are not going to do FOIL. We are going to square the first term. So m times m is m squared. And then I'm going to put a minus sign down. And then I'm going to square the second term. It doesn't matter whether you square minus 3 or 3, because when you square a negative number, it becomes positive. So really, to make life easy, just take the positive number. Now, if you need some more proof, because you've just learnt this, let's just expand it out. M times m is m squared. M times 3 is positive 3m. Minus 3 times m is minus 3m. And minus 3 times 3 is minus 9. And once again, this term and this term will cancel because in the brackets they are the same number but they're opposite in sign. That's why we get the cancelling. So I'm left with the first term squared, which I've got here, and I'm left with the last term squared. And once again, I have a difference. There's the difference of 2 squares. Well, 9 is 3 squared, and m is being squared. So those are my 2 squares. So I really don't want to do FOIL. I strongly advise you against using FOIL. You should be able to recognize this expansion. So here we're going to have first term squared. Well, that would be 2y all squared minus the second term squared. That's 5 squared. If you need to do that extra step, do it. If you don't, and you know that 2y squared is 4y squared and 5 squared is 25, then go straight to the answer. Same here. 3n squared, well, that's 9n squared minus 2p squared, that's 4p squared. So that's how you expand a difference of 2 squares.